Dear students, greetings for the day. Today we will discuss about loading of aircraft with cargo. Safe operation of aircraft requires all hold cargo and baggage to be weighed or an accurate estimate of weight provided by using standard values. It must be loaded correctly and secured to prevent movement in flight. Loading should be in full accordance with the generally applicable regulations and limitations, the operator's loading procedures, and in accordance with the instructions given by the person with overall responsibility for the loading process for a particular flight. These loading instructions must match the requirements for baggage, cargo distribution stated within the aircraft load and trim sheet. In recent years, security considerations have led to rigorous procedures to ensure registered baggage reconciliation Macron, which ensures only accompanied baggage is loaded, unless a special additional validation process for each unaccompanied bag has been followed. Weight distribution between holds has a considerable effect upon the C/G of the aircraft. Load distribution will be specified on the loading instruction form by hold, or by hold compartment in the case of larger underfloor hold areas. Many narrow-body short-haul aircraft are bulk-loaded with loose individual items of baggage and cargo. In this case, baggage loading will be by item count, with prescribed assumptions about the average weight per bag used to complete the load and trim sheet. Precise figures will often vary according to NAR regulations or be more restrictive to meet the aircraft operator Macron's own checked baggage rules. Average checked baggage standard weight assumptions usually vary depending on whether the flight is domestic, international, charter or scheduled. Standard baggage weights must be applied with care. Incidents have occurred where standard weights have seriously understated the actual mass of the loaded baggage, causing both an error in the total mass of the aircraft and a center of gravity outside the approved safe envelope. Netting is used to restrain bulk-loaded loose baggage items within holds so that they do not move in flight. Any load that shifts in flight will move the aircraft Macron's center of gravity and can cause control difficulties, in extreme cases causing loss of control, and prevent baggage door opening post-flight. Cargo netting may also be used to divide larger holds into sections. Most wide-bodied aircraft, and increasingly some narrow bodies, are able to use the much simpler system of aluminum containers called unit load devices. These can be used to consolidate baggage or cargo items before being loaded into the aircraft hold by specialized hydraulic lift equipment. The ULD are then maneuvered manually to a final position on board by use of a roller floor, before being finally secured in position. ULD must either be weighed, or the number of baggage items per container must be within a specified range and standard baggage unit weights applied. Under either system, special procedures may be prescribed for abnormal loads such as those covered by dangerous goods regulations, heavy items, oversize items, items with have unusual dimensions, proportions. Heavy objects which exceed the hold floor loading limit published in the AFM may be able to be carried if prescribed arrangements for load spreading are available and applied. A load instruction report form will be issued for every aircraft departure to instruct loading teams on the quantity of baggage, cargo to be loaded into each hold. Where a computerized or electronic load and trim sheet is prepared on behalf of the operating crew, usually the handling agent or airline will produce the load instruction/report form with reference to the load and trim sheet. The load instruction report form will then be given to the loading supervisor to instruct the load team how the aircraft needs to be loaded and to record formally the actual loading and any deviations. When the operating crew produces a manual load and trim sheet, the crew, in consultation with the loading supervisor, may also complete the load instruction/report form. Once the aircraft is loaded, the load instruction report form is generally provided to the crew for cross-checking against the load and trim sheet, though sometimes the crew are provided with a certificate stating that the baggage cargo has been loaded in accordance with the load and trim sheet instructions. As with the load and trim sheet, there are a number of key entries on the load instruction report form that must be checked for accuracy: airline/operator flight details, routing, flight number and date, aircraft type, variant and registration, distribution of hold loads, including baggage, cargo, ballast, spares, command, and mail, etc. Void/nil fit positions, bags per ULD/whole weight allocation to each compartment does not exceed limits, document edition number, if applicable. The principal risks associated with loading of aircraft holds are as follows. Holds are not loaded by the loading crew in accordance with the loading instructions provided, and the load instruction report form is not amended to reflect these changes. Where the loading has been different to the original loading/report form and the loading report form is updated, the last-minute change has not been correctly applied to the original load sheet calculations and checked for mass and balance limits. The load is not secured or restrained appropriately, unauthorized items are loaded, for example dangerous goods, aircraft structure, or propeller blades if applicable, is damaged by unintended impact from mechanized loading equipment. Such impacts may go unnoticed by the loading team or in some cases is noticed but not reported. This may happen when the load team can see no apparent damage, so consider reporting the impact unnecessary. Where the aircraft structure is formed using composite materials, all impacts must be reported. While evidence of significant damage to a metal structure is usually clearly visible, this is not necessarily true for composite materials. Although the skin may appear to be undamaged, the core of a composite structure may have deformed or have been significantly weakened. AT-43, Madang, Papua New Guinea, OCT 2013, an AT-42 freighter departing Madang had to reject its takeoff when it was impossible to rotate and it ended up semi-submerged in a shallow creek beyond the airfield perimeter. The investigation found that loading had been contrary to instructions and the aircraft had a center of gravity outside the permitted range and was overweight. This was attributed to the aircraft operator Macron's lack of adequate procedures for acceptance and loading of cargo. A lack of appreciation by all parties of the need to effectively mitigate runway overrun risk in the absence of a reserve was also highlighted. B748, Prestwick, UK, 2017. On the 30th of March 2017, a significant amount of fuel was found to be escaping from a Boeing 747-8F as soon as it arrived on stand after landing at Prestwick, and the fire service attended to contain the spill and manage the associated risk of fire and explosion. The investigation found that the fuel had come from a Bell 412 helicopter that was part of the main deck cargo and that this had been certified as drained of fuel when it was not. The shipper Macron's procedures, in particular in respect of their agents in the matter, were found to be deficient. A306, Paris CDG, France, 1997. On 30 July 1997, an Airbus A300-600 being operated by Emirates Airline was departing on a scheduled passenger flight from Paris Charles de Gaulle in daylight when, as the aircraft was accelerating at 40 kts during the takeoff roll, it pitched up and its tail touched the ground violently. The crew abandoned the takeoff and returned to the parking area. The tail of the aircraft was damaged due to the impact with the runway when the plane pitched up. AT-76, Dublin, Ireland, 2015. On the 23rd of July 2015, an AT-72-600 crew suspected their aircraft was unduly tail-heavy in flight. After the flight, they found that all passenger baggage had been loaded in the aft hold, whereas the load sheet indicated that it was all in the forward hold. The investigation found that the person responsible for hold loading as specified had failed to do so, and that this failure had not been detected by the supervising dispatcher who had certified the load sheet presented to the aircraft captain. Similar loading errors, albeit all corrected prior to flight, were found by the operator to be not uncommon. DH-8B, Nuuk, Greenland, 2019. On the 30th of May 2019, a DHC-8-200 departing from Nuuk could not be rotated at the calculated speed even using full aft back pressure, and the takeoff was rejected with the aircraft coming to a stop with 50 meters of the 950-meter-long dry runway remaining. The initial investigation focus was on a potential airworthiness cause associated with the flight control system, but it was eventually found that the actual weights of both passengers and cabin baggage exceeded standard weight assumptions, with the excess also resulting in the aircraft's center of gravity being outside the range certified for safe flight.